Thunderstorm asthma. It sounds kind of made up, right? I mean, we think of rain as a good thing for allergies. It's supposed to wash all the pollen out of the air. But what if I told you that under just the right conditions, a thunderstorm could actually turn that pollen into a hidden danger? A weapon, even, that could cause an entire city to gasp for breath.
So how is that even possible? Well, to get to the bottom of this, we're going to lean on a really fantastic interview with Professor Patrick Spicer. It's from the Science Talks In Other Words series, where they do a great job of breaking down complex science.
This isn't just a theoretical problem. It became terrifyingly real back in 2016 in Melbourne, Australia. A mysterious event completely overwhelmed the city's hospitals. For a few hours, it was like an entire city simply couldn't breathe.
And here's the truly scary part. Professor Spicer points out that many of the people affected had zero history of asthma or breathing problems. And tragically, the consequences were devastating. In his own words, a number of fairly young people actually passed away.
So you can imagine an event like that sets off massive alarm bells. For scientists, it became this huge puzzle that they absolutely had to solve. What on earth was actually happening?
So here is the core of that puzzle. See, pollen grains on their own are actually too large to get deep down into our lungs where the real damage happens. So if that's true, how could they possibly cause a citywide emergency? The answer, it turns out, is that the pollen ruptures. Think about it like this. A whole pollen grain is like a big package that's too big to fit through the mail slot of your lungs. But what happens if that package shatters in the air, releasing hundreds of tiny, potent allergenic particles? Those are small enough to be inhaled deeply, and that's what can trigger such a severe, widespread reaction.
Okay, so that leads to the next obvious question, right? What is powerful enough to crack all of this pollen open at once? The leading hypothesis points its finger directly at the storm itself.
And scientists think it happens in 4 steps. First, powerful storm updrafts suck pollen grains high up into the humid clouds. Up there, they absorb all that moisture and swell up like tiny water balloons. Then, the third step, they burst. They literally rupture, releasing a cloud of those superfine particles. And finally, the storm's downdrafts push this invisible, allergenic cloud right back down to the ground where we breathe.
So that's the theory. But in science, a theory isn't enough. You've got to prove it. And that's why researchers are basically in a race against time, trying to create a reliable warning system based on this mechanism. And they are making some serious headway. It's actually pretty cool. Professor Spicer says his team is now able to see this happen in the lab. They are, quote, directly observing pollen grains rupturing under simulated storm conditions.
And a problem this big isn't solved by one person. It takes a massive collaboration. We're talking experts in chemical engineering, pollen biology, plasma physics, and cell biology all working together. It's a real all-hands-on-deck effort.
So, where does that leave us? Well, the research team is about halfway through their 3-year project. That means we could be looking at definitive answers in just a year and a half. That's really not that far off. The end goal here is simple: to save lives. And it all leads to this really interesting question for the future. Could pollen burst warnings one day become a standard part of our daily weather forecast? Just imagine that.